Hello. Today I have Philip de Ryck with me. Hi, Philip.
Hi, Manfred. How are things with you?
Yeah, I cannot complain enough. No, everything is fine. Thanks. How are you?
Yeah, I shouldn't complain, but sometimes I like to complain. I just realized I miss people, as in I haven't seen people at a live event in a very long time, and people are switching companies, and I only find out when my mails bounce, for example, like, oh yeah, that person left the company because I haven't seen anyone in such a long time. But I'm still talking security and doing security, so there's that, and that's pretty good.
Awesome. Yeah, I really feel you about the current situation. So today we want to talk a bit about cross-site scripting and one technique to deal with it or to prevent it, namely CSP. So perhaps we can start with cross-site scripting. What is it and why is it still a thing? Because I think it has been around for decades, hasn't it?
Yeah, cross-site scripting is as old as JavaScript basically, because it's basically a trick where the attacker manages to execute JavaScript code or well any other type of code that runs in a web application, for that matter. But VB script is dead, so that doesn't count anymore. But it's a trick where the attacker manages to execute JavaScript code in a victim application used by a normal application user. So let's say that you visit a forum and you see a cool blog post, and all of a sudden some JavaScript starts executing in your browser because I put that in my forum post. That's not supposed to happen, and that would be a cross-site scripting vulnerability. And the effects are disastrous, right? I mean, at that point, you're executing my code in your browser, in your session with that forum, so I can do whatever I want. And I can start posting things like micro frontends are crap and things like that. And yeah,
Don't do
and
this. Don't
based
do
on your
this.
reaction, that would be very problematic. It would kill your reputation, basically. Yeah, but that's not everything. My code can read data, change the page, send requests to the backend. Basically, anything a front end developer can do, an attacker with a cross-site scripting vulnerability can do as well.
Mhm. That really sounds serious. So perhaps we should shut down the web because of this. But there is one hero on the horizon, namely CSP. And CSP is said to be one solution that helps to deal with this. What is CSP?
Yeah, I don't like to frame it as a solution against cross-site scripting. So CSP, let's be honest here, CSP is a mess. Let's start there. I mean, CSP stands for Content Security Policy, and it's been around for a long time as well. I mean, it's nearing 10 years of lifetime now. And CSP started out as this security policy, which gives you as a developer or administrator control over what can be loaded in your web application. So you'd define a policy that states like, oh, I want to load script from here and maybe some images from there and a font from there and so on and so on. And essentially that kind of makes sense. And the idea was that CSP could act as a second line of defense against cross-site scripting. As in, you do your best as a developer to avoid the problem, but in case something goes wrong, which history shows us is going to come one day or another, in case something goes wrong, maybe if you have deployed CSP, we can use that in a way to restrict the attacker in one sense, or even prevent the attack from executing altogether. And that's what CSP is. And that's why I don't like to call it a solution,
Mhm.
because it doesn't absolve you of the responsibility of handling cross-site scripting in your application code in the first place, which is something that Angular does quite well, by the way.
Cool, cool. So technically speaking, what is CSP? Is it a text file? Is it a configuration on your server? How can we imagine this?
Yeah, it's a security policy that you send from your server, and the browser enforces that on your application, basically. So the default way to deploy CSP would be to send it as a response header alongside with your index.html file, and the browser, well, any modern browser, so basically everything that's not Internet Explorer, will recognize that CSP header and will understand like, oh, you want me to enforce this policy on this page and everything that's loaded in the page, I'll do that for you. There's other deployment mechanisms as well, but this is the way CSP is supposed to be deployed.
Cool. And then it tells my browser, hey, this application is only allowed to grab pictures from here and scripts from there. Is that right?
Yes, that's a theory.
That's the theory. Okay.
In practice, it's a little bit more difficult. Well, no, it depends. And the simplest policy would just tell the browser, like, hey, this application just uses files from itself. Not from anywhere else. We don't load crap from the internet, and we don't want images from God knows where and scripts from advertisers. No, we just use our own resources, and we're very happy with doing that. And that is the ultimate dream scenario for CSP, because it will take you 5 minutes to set it up. It will work like a charm, and you are done, basically. You have applied an additional layer of protection for your application. But of course, you know as well as I do that we don't really build applications like that. Security people wish we did, but in reality, it's going to be like, oh yeah, let's load some stuff from here and maybe drop a file in from there. Oh, there's some JavaScript on the CDN we can use. And oh, you want a Facebook like button. Here's a piece of JavaScript you have to put in your page. And approving all of these definitely takes some effort, because that's where the messy part of CSP comes in. There's a whole bunch of guidelines on how to build a secure CSP policy that still allows legitimate third-party code to execute without opening up your application for major attack vectors, major cross-site scripting vulnerabilities, basically.
Sounds interesting, yeah. So what's with Angular? Is Angular compatible with CSP?
Sure. On paper, Angular is a dream framework for CSP, because Angular doesn't conflict with CSP. As in, CSP has some limitations, like you can't use onClick in HTML, but if you write Angular code, you still right-click, but it's not an on-click from the DOM. Angular will translate that into an add event listener behind the scenes, and that's the proper way to write code. So yeah, Angular is really, really, really compatible with CSP, which is awesome. Deploying Angular applications, not so much, because the way we deploy single-page applications has some issues. Like, you have a static file bundle, a static application bundle. You drop that on a CDN somewhere and browsers load it. But first of all, adding headers already gets a bit tricky. Not impossible, but it gets a bit tricky. And then there's a bunch of security mechanisms in CSP to make it more secure that rely injecting data on the server side when rendering the page, which kind of doesn't really happen when you serve an index.html from a CDN. So yeah, the deployment model makes things a bit tricky.
Okay. So do you even though recommend that developers deploy CSP for Angular?
You don't ask easy questions now, do you? It depends. Initially, if you would come to me as a developer and you're like, yeah, the security thing, I'm not really sure how or what, shall I deploy CSP? My answer is going to be like, no, absolutely not. Why not? Because CSP is, we talked about this before, CSP is a second line of defense, a secondary defense, and it doesn't absolve you of the responsibility of trying to get it right in the first place. So my recommendation in that case would be, I have a cheat sheet for Angular security on my website and a blog post on cross-site scripting in Angular. I would say, look that up and make sure you don't make these and these mistakes. Make sure you already follow best practices. That's going to be much more useful in case you have a vulnerability to fix it in the code instead of trying to patch the hole with CSP afterwards. And only if you've done that, only if you've done your job well, basically, then I would recommend you look into CSP to add as a second line of defense in case something still goes wrong in the future, or in case a vulnerability is added later in the application, then you might have CSP in place to kind of catch it when it happens.
I see. So can you give us 1 or 2 hints about what we should do to do it right in the first place?
Yeah, sure. The first tip is maybe the most important one. Get out of the way of Angular, because Angular has very, very solid built-in cross-site scripting defenses. So if you do things the Angular way, chances are that you will not have a cross-site scripting vulnerability, because when you use inner HTML in Angular, for example, Angular automatically sanitizes the data. So let Angular do what it does best, and it will help protect you. That's maybe the first important thing. And then the second thing, and that's what I discuss in detail in my Angular security workshops, is you'll run into scenarios where Angular is trying to help you, but it's too helpful. It's kind of getting in the way of what you really want to achieve, and that's typically where we get into the danger zone, if you want to call it that, because there are ways to sidestep Angular. There are ways to say like, yeah, let me just handle this on my own, and that literally means you're on your own. And there you'll have to ensure that you do things securely yourself, and those are the tricky parts, basically. So that's when you're trying to do your own sanitization, for example. That's a pattern to look out for, that you want to make sure you get that right. Or if you try to mess with the DOM natively, there's ways to break out of Angular and be like, just give me the DOM and I'll deal with elements myself. Well, that's not always, but that could definitely be a recipe for disaster. So it's basically
those ugly method names, are they?
Yeah, something like that. And then you can also reach the inner HTML and drop some HTML in there directly, and a browser will happily render that for you, and you'll have massive cross-site scripting vulnerabilities. And the Angular people are probably like, told you so, you should have used the Angular way, and that's how it goes. So yeah, to summarize, get out of the way of Angular, because Angular does it really well, so that's good. And if you have to do it yourself, really invest some time in understanding how DOM-based cross-site scripting works, because adding such a vulnerability is easier than you think.
Awesome. Don't bypass your main framework. Should be clear, but obviously it isn't. I guess it happens.
Yeah, but we've had this in one of the previous workshops that I did for you. One of the participants was like, they found a vulnerability during the workshop because of the things I was explaining, because they actually sidestepped Angular because Angular was too strict. It was too harsh on what they needed. It didn't allow them to enable a use case for a customer. And the workaround that they found was the very insecure workaround. So when I explained this is not the way to do it, they were like, oh crap. And they actually looked in their application like, yeah, we did that wrong. And they were able to fix it because of that.
That's an awesome story, isn't it? Because it gives you immediately value in this case. You visit a workshop and you get immediately value out of it.
Yeah, absolutely. And I get to say like, see, this is actually really, really relevant, because here's one of your colleagues that had this exact problem in their application. And yeah, that's the best thing that can happen in a workshop.
Nice. So what's with third-party vendor NPM packages? Sometimes they are a bit fishy. How can we protect from this? How can we protect from them to inject source code that is harming our website?
Yeah. Do you want the real answer, or do you want the blissful ignorance answer?
Perhaps both.
Both. The real answer, the only real way is to analyze the code. I mean, you're installing, you're pulling in third-party code. You have zero idea what you're pulling in. The only real way to make sure that this is valid is actually open up the code and inspect what it's doing and whether you think that's okay or not. That's, of course, not a feasible answer. I mean, just doing npm or ng new in Angular is going to give you like I think I did this once for a presentation, like 1 million lines of code. I mean, there's no way to do that in practice. So the best thing we have right now is working together to try and secure the ecosystem, scanning packages for potential malware, trying to find and report vulnerabilities, fixing them, keeping your dependencies up to date, and all of that, monitoring dependencies for known vulnerabilities. That's the best thing we have for now, and hopefully we'll be able to improve on that in the future.
That means we need to rely on third-party vendor tools that is specialized into scanning NPM packages. Is that right?
Yeah, there's a whole bunch of open source alternatives available. Like NPM has the built-in NPM audit, which is basically a match of package versions against known vulnerabilities. There are free and open source scanning tools, like OWASP has a dependency check tool that you can use as well. And of course, vendors have made this their problem as well by offering commercial solutions, some of them free, some of them very expensive. But yeah, it's tool support is the only way to actually tackle this problem right now. Oh, and GitHub, by the way, has the built-in dependency graph, which is also alerting you of potential issues in your dependencies. So yeah,
Oh, that's
plenty of
nice.
options.
Cool. So would you recommend to write more stuff by yourself and to prevent using third-party vendor stuff from out there? I mean, we cannot rewrite Angular, but when it comes to tinier
What
libraries,
do you mean you cannot rewrite Angular? You have
yeah,
to show some commitment and really push forward. And
okay, gotcha.
no, of course not. So, well, it depends. Maybe you should write some code yourself. I mean, there have been vulnerabilities in npm packages that really don't do anything useful, like reverse a string. Honestly, I think we can kind of manage that ourselves without having to install a crazy dependency for that. Other than that, it's obviously not feasible to do things yourself, especially when it comes to frameworks like Angular, React, and all of those things. So reputation would be the next best thing. There are tools. The Snyk is one of these commercial vendors doing dependency scanning, but they have a free tool called Snyk Advisor, where you can enter a package name and it will give you like a health score, which is an estimate of how well the package is maintained and how many known vulnerabilities there are still open and so on and so on. And that gives you a good idea. So, for example, a friend of mine asked me about a library for, don't tell anyone, for React, for doing something in React. And he asked me, like, is this a good security library? And I was like, I don't know, because there's so many and I have no idea. And I plugged it in there and the health score was like 43 or something. I was like, yeah, this thing hasn't been updated in the last 5 years, so probably you want to use something else. And so that really helps. But of course, it's just a heuristic and anything can happen in the current ecosystem. But choosing dependencies wisely will definitely help you avoid the bad neighborhoods of npm, basically.
Okay, cool. So one topic that seems to be somehow related to CSP is trusted types. I've seen you've given a nice talk on NGPE last year. I think it was last December or November. So how does trusted types help? Or how do trusted types help?
Yeah, I did speak about that at NGPE in December. I'm not sure if the videos are online, but they should be. And if they're not, then it should be online shortly. So trusted types is a new type of behavior in the browser, and it's related to CSP because you enable trusted types through a CSP policy. So there's a new directive for CSP, require trusted types for, that tells the browser like, hey, I want to enable this trusted types thing. Trusted types helps in the sense that it will, or when you enable it, the browser will refuse to assign text to inner HTML. So you know this pattern where you just write some HTML yourself and you drop a variable in between those HTML tags coming from user input and you throw that into a page. Well, that's basically your DOM-based cross-site scripting vulnerability that you've just created. And with trusted types, you can tell the browser like, yeah, we don't do that anymore. And the browser will tell you like, okay, good. No text-based assignments. It will basically throw a type error and be like, text? No, I don't do strings anymore. Go away. And the browser will force you to transform that text into a trusted type, which also implies that you apply security on that text before putting it in there. So it's not a security mechanism per se. It's more like a type restriction in the browser that forces you to apply a security mechanism. So you can enable that for your app, and all of a sudden, if you get like 500 errors in the browser, especially in an Angular app, because Angular does trusted types by default if you enable it. So if you get 500 errors, that's 500 places in your application where you're circumventing the built-in Angular security mechanism and assigning something in the DOM directly, and all of those are potential vulnerabilities. So you'll have to look at that, triage them, and secure those calls so they work with trusted types. That's why I love it so much.
Oh, cool. That would be my next question. Do you recommend it? You said you love it that much, so you will recommend it, or you would recommend it. Is that right?
Yeah, well, the beauty of trusted types is that it always works, right? I mean, you don't have to use it in production for having the benefits of trusted types, because if you enable that in development mode, then guess what? Everything you do that is a potential insecure way of doing things is going to break in development mode. So you're going to be like, oh crap, this doesn't work. And you'll have to fix it. You'll hopefully write the correct code to fix it, which will automatically apply security while creating that trusted type data. And at that point, the potential vulnerability has disappeared. So yeah, I definitely recommend using trusted types because it will alert you when you're doing something fishy that you probably shouldn't be doing. So when you copy paste that Stack Overflow code snippet and all of a sudden you get trusted types errors, then you know that you copy pasted the wrong thing and you should probably look a bit further for the correct answer.
Awesome, awesome. So you've already mentioned the workshop you will do in a couple of weeks. And can you tell us a bit about this Angular security workshop?
Yes, it is about Angular and security, and it's a workshop. So yeah, it's funny that you asked this because you obviously know about the workshop since you're organizing it or hosting it. But we've been doing this for, this is the fifth edition? I don't remember.
So,
we've been doing this for a while. And it's basically a 2-day security workshop. Well, sometimes it's 4 half days, but it's still 2 days then. It's a 2-day security workshop where we focus on security principles for Angular applications. And we cover, basically, we start with the basics, like how does the browser think about security, which is very surprising because most developers are like, yeah, we never knew about that. It's like the fundamentals of what the browser uses as security boundaries, and developers are like, oh, that's news to us. It's like really important to understand that. And then we'll dive into cross-site scripting. We'll look at what Angular does well, which is a lot. We'll look at how things can go wrong even when you use Angular, how to fix that. We'll talk about trusted types in detail with some examples. We dive into a lot of CSP content, like all of the things I couldn't answer here because it literally takes me half an hour to explain how to do that correctly in CSP. We cover those in much detail. There's some hands-on lab sessions where you can try things out yourself. And at the end, you'll basically have a list of best practices on what not to do in Angular. So that's a good thing, how to do it correctly, and then how to apply these browser-based defenses like CSP, like trusted types, well, to ensure you have, or you can increase the security of your application.
Nice.
That's, yeah, absolutely. The feedback on the workshop is always absolutely wonderful. People have found real vulnerabilities in their applications throughout the workshop, and it's a lot of fun to teach and participate as well.
Awesome. So who should attend?
Everyone. the more the merrier. No, seriously. Definitely architects and developers, preferably for Angular applications because it's kind of Angular oriented. Unless you're a React developer and you want to peek across the fence, then I would say come and join us because it's going to be interesting anyway. And things like CSP obviously apply to React and Vue and Ember and so on because it's a browser-based technology. It's not Angular specific. But yeah, it's oriented towards developers, architects, maybe security professionals working in Angular environments that want to know the ins and outs of Angular security. Those are also very welcome. So yeah, absolutely.
Cool. Sounds great. So Philippe, thanks for being here today with us. I'm really looking forward to this workshop. I will also link it below. And yeah, have a nice day. See you at the workshop.
Yeah, absolutely. Thanks for having me, and see you at the workshop soon.
Bye.
All right. Bye-bye.